Hello, everybody. This is Mr. Walker. Our lesson topic today is called Making Sense of Remainders in Division. I like to call it Using Common Sense. We've already had lessons on long division strategies, work with remainders 2 and 3 digit. This is really not about how to do long division as much as it is using common sense in answering certain kinds of questions that involve remainders. By the end of this video, you will be able to interpret 4 types of problems that have remainders when solving real-life problems. Let's go ahead and solve this. We're going to use this same problem for most of our examples today. 29 divided by 6, we work from left to right, digit by digit. 6 does not go into 2, but 6 does go into 29. I could show that by using multiplication. Use my 6 and then my 29. If I go and use a multiplication chart, I can see that 6, the closest I can get without going over would be 24, and that would be 4. So to solve for n would be 4, but it does not equal 29. It equals 24. I'm going to circle and use both numbers, 4, and then our 24. We subtract to see how close we got, and that would be 5. So 29 divided by 6 is 4 with a remainder of 5. We're going to use this same problem for several examples. Remember, our topic today is making sense of remainders using common sense. Let's just discuss as review some vocabulary and concepts. Remember that division involves equal groups, or the concept of fair share. But when you are solving problems, not only in real life, but when you're solving them for tests, don't forget to use good old-fashioned common sense. Here's an example. 29 students in a classroom, but there are only 6 lab sets. That's a common problem that we run into, right? Well, here's the math. We did that problem on the previous page. 29 divided by 6 is equal to 4 with the remainder of 5. But remember, in this case, the 29 is representing people, students. And I just put a note here that it's really 29 people. And that when we have a remainder of 5, the 5 is representing 5 people. The 6 is representing our lab sets, but the 4 and the remainder 5 represents people. Now, why is that important? Well, I showed that by drawing 29 circles that represent our people, and we determined that we have a total of 6 groups of 4, or 6 sets of 4. And I'm going to show that right here. The second set, the third set, a fourth set, a fifth, and a sixth set. We have one set, so these are our lab sets, 3. And each of these groups have 4, 1, 2, 3, 4, and we could count that across, and that's our 4. Our remainder is 1, 2, 3, 4, 5, but remember that this is these are people. So in real life, yes, technically it's 4 remainder 5, but in real life we would not exclude these 5 people. We would include them, meaning that one of the groups would not be equal. That goes against what we've taught about equal groups. That's true. But in real life, don't forget good old-fashioned common sense. So, yes, we would like equal groups. We would strive for equal groups. But in this case, we may need to make the groups. You may need to answer that on the test question, and I'll show you some more of that later. We're going to discuss, we said, 4 types of problems. We already solved the problem here. Type 1, the remainder is not needed. It can be discarded. Well, by that, we're talking about the remainder. In this case, we have 29 pencils to be shared fairly with 6 friends. There's our 6, there's the 29 pencils. How many pencils will each friend receive? Well, according to this, each friend would get 4 pencils, again, evenly, but 5 are left over. Well, in this case, pencils are just pencils. It's not really super important. So for this problem, we could stick with this and the remainder would just be 4 pencils, maybe sitting off in a drawer or something. So the idea here is that sometimes a remainder is not really important. So when you have things like pencils, right, paper clips, beads, trinkets, it's probably not super important. So they could be discarded or not really dealt with. The 4 would be the main thing to do it evenly. The second kind of problem is where our remainder is partitioned. Partition means to be put into sections and shown as a fraction. Here's an example. 6 friends, there's our 6 right here, share 29 ounces of juice. How many ounces will each person get if all of the juice is shared equally? Well, we did the same problem. We said that it's going to be, in this case, how many ounces? 4 ounces, but that there would be 5 ounces left over. And in this case, imagine here that this is our 29 ounces, and this would be juice. I guess the green is not the best color for juice. I don't know what kind of juice is green. Maybe it's Mountain Dew. We'll say it's Mountain Dew soda, right? And in real life, if you were splitting a drink, you probably would empty the container. So in this case, when we partition or show a fraction, technically we would express this remainder as 5, 6, or in other words, we would say 4 and 5, 6. Now, I want to be clear, the purpose of this lesson is to teach my 4th grade students. And remainders with expressed as fractions is really a 5th grade skill. But again, I want the class to be mindful that sometimes the remainder is divvied up, and instead of just 4 ounces, it really would be technically 4 and 5, 6 ounces when you have a problem like this. If it's something that you're struggling with, I wouldn't be too concerned. I want you to be aware of it. The third type of problem is when the remainder forces the answer to be increased to the next highest whole number. This is one I want you to pay attention. This is more common. There are 29 people. There's our 29 going to a party by car. I'm representing cars here. How many cars will be needed if each car holds only 6 people? There's our 6. And notice that we have our answer of 4 with a remainder of 5. So here you can see that we would have 6 people in the first car, 6 people in the second, 6 and 6 in the fourth, but we would have a problem here because here we have 5 remaining. In other words, we're talking about 5 people. 1, 2, 3, 4, 5 who can't fit in the cars. In this case, in a real life situation, these people would not be left behind. They would actually have to get another car. So in this case, it would not just be 4 cars, it would be 5. Again, the argument is, well, isn't the math 4 with a remainder of 5? Yes, that's true. But we talked about using common sense. In a real life, nobody would leave 5 people behind. They would say, well, we need to get another car because the math is not working for us. We can't get everything even. So keep these kind of problems in mind. Again, we're talking about using common sense. The fourth type of problem is the remainder forces the answer to be rounded or to give an approximate answer. Here's an example. 6 children, there's our 6, will share a bag of candy containing 29 pieces. About how many pieces of candy will each child get? Well, our answer, like always, was 4 with a remainder of 5. In this case, they want us to estimate that word about. And we remember for estimating division, we use compatible numbers. So I'm going to rewrite that very quickly. It's 29 divided by 6 equals, I want to find a compatible number for 6. I'll show that to you here. I want to get as close to 29, and in this case, I am allowed to go over. The closest is 30, and you can see that that would be 5. So I'm going to rewrite this as 30 divided by 6 is equal to 5. In this case, we would say, well, each student gets about 5 pieces of candy. Remember, about is just close. Technically, yes, 4 with a remainder of 5. But the way that this problem is worded, if this was given as an answer option, that would be the best answer because of the word about. Here's a real life example. This could also be a problem. I actually picked this problem up off of a test. A house builder needs to buy 19 boards at Lowe's home improvement store. If the boards he needs come in packages of 6, how many packages does he need to buy? Well, he needs 19 boards. And it says that the boards come in packages of 6. That's word form, but I can convert that to standard form. So we're looking at 19 divided by 6, 19 boards. If I use my strategy of multiplication to solve division, I know that it would be 6 times 3 is the closest I can get. It will equal 18. So it doesn't equal 19. It equals 18. I'm going to circle and use both numbers. And you can see that I got close, but I still have a remainder of 1. Now, let's go back to the question. He needs 19 boards for his project. It comes in packages of 6. If we divide that, we get 3 packages with a remainder of 1. The problem is if he buys 3 packages, he will have how many? 18 boards. Well, is that enough? No, he needs 19. He was short 1 board. So does he need to buy 3 packages? The answer to that is no. He will not have enough. He would have to buy 4 packages, and yes, he will have some extra boards, and it would not be 19 or 6. So this is an example of when you need to interpret division. So in review, our lesson topic today is making sense of remainders when dividing. And the key idea that I want to stress today is this whole idea of when you solve problems, make sure that you are thinking and using common sense. There are 4 types. Sometimes your remainder is not needed. It can be discarded. Sometimes the remainder is shown as a fraction or partition. We had the juice example for that. Type 3, sometimes it forces the answer to be increased to the next whole number. We just showed that on the previous problem about the boards and having to buy more packages, and also with the vans. And then sometimes a remainder forces the answer to be rounded, and that's where we use estimating and compatible numbers. Okay, everybody, this is a tricky lesson to teach. Hopefully, it was helpful, and we'll see you next time.